Scala is an object functional programming and scripting language for general software applications. Scala has full support for functional programming and a very strong static type system. This allows programs written in Scala to be very concise and thus smaller in size than most general-purpose programming languages. Many of Scala's design decisions were inspired by criticism over the shortcomings of Java. Scala's source code is intended to be compiled to Java bytecode, so that the resulting executable code runs on a Java virtual machine. Java libraries may be used directly in Scala code, and vice versa. Like Java, Scala is statically typed and object-oriented, and uses a curly brace syntax reminiscent of the C programming language. Unlike Java, Scala has many features of functional programming languages like scheme, standard ML and Haskell, including anonymous functions, type inference, list comprehensions, and lazy initialization. Scala also has extensive language and library support for pattern matching, delimited continuations, higher-order types, covariance and contravariance, and for avoiding side effects. Scala has a unified type system, meaning that all types are subclasses of the type any. This is similar to C but unlike Java. Scala likewise has other features present in C but not Java, including anonymous types, operator overloading, optional parameters, named parameters, raw strings, and no checked exceptions. The name Scala is a portmanteau of scalable and language, signifying that it is designed to grow with the demands of its users. History: the design of Scala started in 2001 at the École Polytechnique for copyright d'art copyright Rail de Lausanne by Martin Odesky, following on from work on Funnel, a programming language combining ideas from functional programming and Petri nets. Odesky had previously worked on generic Java and Javac, Sun's Java compiler. Scala was released internally in late 2003, before being released publicly in early 2004 on the Java platform, and on the .NET platform in June 2004. A second version of the language, v2.0, was released in March 2006. The .NET support was officially dropped in 2012. On January 17, 2011 the Scala team won a 5-year research grant of over $2.3 million from the European Research Council. On May 12, 2011, Odesky and collaborators launched Typesafe Incorporated, a company to provide commercial support, training, and services for Scala. Typesafe received a $3 million investment from Greylock Partners. Platforms and license: Scala runs on the Java platform and is compatible with existing Java programs. It also runs on Android smartphones. The Scala software distribution, including compiler and libraries, is released under a BSD license. Examples: Hello World example, the Hello World program written in Scala has this form. Unlike the standalone Hello World application for Java, there is no class declaration and nothing is declared to be static. A singleton object created with the object keyword is used instead. With the program saved in a file named Hello World Scala, it can be compiled from the command line, $SKAH-lə Hello World Scala, to run it, $SKAH-lə Hello World. This is analogous to the process for compiling and running Java code. Indeed, Scala's compilation and execution model is identical to that of Java, making it compatible with Java build tools such as Ant. A shorter version of the Hello World Scala program is saved in a file named Hello World 2 Scala. This can be run as a script without prior compilation using $SKAH-lə Hello World 2 Scala. Commands can also be entered directly into the Scala interpreter, using the option $SKAH-lə println, Hello, World. A basic example: the following example shows the differences between Java and Scala syntax. Some syntactic differences in this code are: Scala does not require semicolons to end statements. Value types are capitalized, int, double, boolean instead of int, double, boolean. Parameter and return types follow, as in Pascal, rather than precede as in C. Functions must be preceded by def. Local or class variables must be preceded by val or var. The return operator is unnecessary in a function. The value of the last executed statement or expression is normally the function's value. Instead of the Java cast operator foo, Scala uses foo as instance of type, or a specialized function such as to double or to int. Instead of Java's import foo, Scala uses import foo. Function or method foo can also be called as just foo. Method thread send, signo, can also be called as just thread send signo. And method foo to string can also be called as just foo to string. These syntactic relaxations are designed to allow support for domain-specific languages. Some other basic syntactic differences: array references are written like function calls, for example array, I, rather than array, I. Generic types are written as for example list, string rather than Java's list string. Instead of the pseudo-type void, Scala has the actual singleton class unit. An example with classes: the following example contrasts the definition of classes in Java and Scala. The above code shows some of the conceptual differences between Java and Scala's handling of classes. Scala has no static variables or methods. Instead, it has singleton objects, which are essentially classes with only one object in the class. Singleton objects are declared using object instead of class. It is common to place static variables and methods in a singleton object with the same name as the class name, which is then known as a companion object. In place of constructor parameters, Scala has class parameters, which are placed on the class itself, similar to parameters to a function. When declared with a val or var modifier, fields are also defined with the same name, and automatically initialized from the class parameters and mutator methods, which are automatically created. The accessor function has the same name as the field, which is why it's unnecessary in the above example to explicitly declare accessor methods. Note that alternative constructors can also be declared, as in Java. Code that would go into the default constructor goes directly at class level. Default visibility in Scala is public. Features: Scala has the same compilation model as Java and C, namely separate compilation and dynamic class loading, so that Scala code can call Java libraries, or .NET libraries in the .NET implementation. Scala's operational characteristics are the same as Java's. The Scala compiler generates bytecode that is nearly identical to that generated by the Java compiler. In fact, Scala code can be decompiled to readable Java code, with the exception of certain constructor operations. To the JVM, Scala code and Java code are indistinguishable. The only difference is a single extra runtime library, Scala Library Jar. Scala adds a large number of features compared with Java, and has some fundamental differences in its underlying model of expressions and types, which make the language theoretically cleaner and eliminate a number of corner cases in Java. From the Scala perspective, this is practically important because a number of additional features in Scala are also available in C. Examples include syntactic flexibility. As mentioned above, Scala has a good deal of syntactic flexibility, compared with Java. The following are some examples: semicolons are unnecessary. Lines are automatically joined if they begin or end with a token that cannot normally come in this position, or if there are unclosed parentheses or brackets. Any method can be used as an infix operator, for example %d apples format, num, and %d apples format num are equivalent. In fact, arithmetic operators like plus and are treated just like any other methods, since function names are allowed to consist of sequences of arbitrary symbols. The only special treatment that such symbol-named methods undergo concerns the handling of precedence. Methods apply and update have syntactic short forms. Foo euro, where foo is a value euro is short for foo apply, and foo equals 42 is short for foo update, 42. Similarly, foo, 42, is short for foo apply, 42, and foo, 4, equals 2 is short for foo update, 4, 2. This is used for collection classes and extends to many other cases, such as STM cells. Scala distinguishes between no parens and empty parens equals 42 methods. When calling an empty parens method, the parentheses may be omitted, which is useful when calling into Java libraries which do not know this distinction. For example, using foo to string instead of foo to string. By convention, a method should be defined with empty parens when it performs side effects. Method names ending in colon expect the argument on the left-hand side and the receiver on the right-hand side. For example, the for a 2 a nil is the same as nil, 2. For, the first form corresponding visually to the result. Class body variables can be transparently implemented as separate getter and setter methods. For trait foo like var int, an implementation may be object foo extends foo like private var x equals 0. Def bar equals x. Def bar equals value, int, x equals value. The call site will still be able to use a concise foo bar equals 42. The use of curly braces instead of parentheses is allowed in method calls. This allows pure library implementations of new control structures. For example, breakable. If break looks as if breakable was a language-defined keyword, but really is just a method taking a thunk argument. Methods that take thunks or functions often place these in a second parameter list, allowing to mix parentheses and curly braces syntax. Vector fill, for, math random is the same as vector fill, for, math random. The curly braces variant allows the expression to span multiple lines. For expressions can accommodate any type that defines monadic methods such as map, flat map and filter. By themselves, these may seem like questionable choices, but collectively they serve the purpose of allowing domain-specific languages to be defined in Scala without needing to extend the compiler. For example, Erlang's special syntax for sending a message to an actor, that is actora. Message can be implemented in a Scala library without needing language extensions. Unified type system, Java makes a sharp distinction between primitive types and reference types. Only reference types are part of the inheritance scheme, deriving from Java lang object. In Scala, however, all types inherit from a top-level class any, whose immediate children are any val and any ref. This means that the Java distinction between primitive types and box types is not present in Scala. Boxing and unboxing is completely transparent to the user. Scala 2.10 allows for new value types to be defined by the user. For expressions, instead of the Java for-each loops for looping through an iterator, Scala has a much more powerful concept of for expressions. These are similar to list comprehensions in languages such as Haskell, or a combination of list comprehensions and generator expressions in Python. For expressions using the yield keyword allow a new collection to be generated by iterating over an existing one, returning a new collection of the same type. They are translated by the compiler into a series of map, flat map and filter calls. Where yield is not used, the code approximates to an imperative-style loop, by translating to for each. A simple example is the result of running it is the following vector, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48, 50. Note that the expression 1 to 25 is not special syntax. The method to is rather defined in the standard Scala library as an extension method on integers, using a technique known as implicit conversions that allows new methods to be added to existing types. A more complex example of iterating over a map is expression mentions is an example of pattern matching. Iterating over a map returns a set of key-value tuples, and pattern matching allows the tuples to easily be destructured into separate variables for the key and value. Similarly, the result of the comprehension also returns key-value tuples, which are automatically built back up into a map because the source object is a map. Note that if mentions instead held a list, set, array or other collection of tuples, exactly the same code above would yield a new collection of the same type. Functional tendencies. While supporting all of the object-oriented features available in Java, Scala also provides a large number of capabilities that are normally found only in functional programming languages. Together, these features allow Scala programs to be written in an almost completely functional style, and also allow functional and object-oriented styles to be mixed. Examples are, no distinction between statements and expressions, type inference, anonymous functions with capturing semantics, immutable variables and objects, lazy evaluation, delimited continuations, higher-order functions, nested functions, currying, pattern matching, algebraic data types, tuples, everything is an expression, unlike C or Java, but similar to languages such as Lisp. Scala makes no distinction between statements and expressions. All statements are in fact expressions that evaluate to some value. Functions that would be declared as returning void in C or Java, and statements like while that logically do not return a value, are in Scala considered to return the type unit, which is a singleton type, with only one object of that type. Functions and operators that never return at all logically have return type nothing, a special type containing no objects. That is, a bottom type, that is a subclass of every possible type. Similarly, an if-then-else statement is actually an expression, which produces a value, that is the result of evaluating one of the two branches. This means that such a block of code can be inserted wherever an expression is desired, obviating the need for a ternary operator in Scala. For similar reasons, return statements are unnecessary in Scala, and in fact are discouraged. As in Lisp, the last expression in a block of code is the value of that block of code, and if the block of code is the body of a function, it will be returned by the function. To make it clear that all expressions are functions, even methods that return unit are written with an equals sign. Or equivalently. Type inference, due to type inference, the type of variables, function return values, and many other expressions can typically be omitted, as the compiler can deduce it. Examples are val x equals foo, or var x equals 1.5. Type inference in Scala is essentially local, in contrast to the more global Hindley-Milner algorithm used in Haskell, ML and other more purely functional languages. This is done to facilitate object-oriented programming. The result is that certain types still need to be declared, for example. Or anonymous functions. In Scala, functions are objects, and a convenient syntax exists for specifying anonymous functions. An example is the expression x equals x less than 2, which specifies a function with a single parameter, that compares its argument to see if it is less than 2. It is equivalent to the Lisp form. Note that neither the type of x nor the return type need be explicitly specified, and can generally be inferred by type inference. But they can be explicitly specified, for example as equals x less than 2 or even equals boolean. Anonymous functions behave as true closures in that they automatically capture any variables that are lexically available in the environment of the enclosing function. Those variables will be available even after the enclosing function returns, and unlike in the case of Java's anonymous inner classes do not need to be declared as final. An even shorter form of anonymous function uses placeholder variables, for example, the following, list map x equals SKAH-lə, x, can be written more concisely as, list map SKAH-lə, immutability. Scala enforces a distinction between immutable variables, whose value cannot be changed once assigned, and mutable variables, which can be changed. A similar distinction is made between immutable and mutable objects. The distinction must be made when a variable is declared. Immutable variables are declared with var while mutable variables use var. Similarly, all of the collection objects in Scala, for example linked lists, arrays, sets and hash tables, are available in mutable and immutable variants, with the immutable variant considered the more basic and default implementation. The immutable variants are persistent data types in that they create a new object that encloses the old object and adds the new member, s. This is similar to how linked lists are built up in Lisp, where elements are prepended by creating a new cons cell with a pointer to the new element in the old list. Persistent structures of this sort essentially remember the entire history of operations and allow for very easy concurrency. No locks are needed as no shared objects are ever modified. Lazy evaluation. Evaluation is strict by default. In other words, Scala evaluates expressions as soon as they are available, rather than as needed. However, You can declare a variable non-strict with a lazy keyword, meaning that the code to produce the variable's value will not be evaluated until the first time the variable is referenced. Non-strict collections of various types also exist, and any collection can be made non-strict with the view method. Non-strict collections provide a good semantic fit to things like server-produced data, where the evaluation of the code to generate later elements of a list only happens when the elements are actually needed. Tail recursion. Functional programming languages commonly provide tail call optimization to allow for extensive use of recursion without stack overflow problems. Limitations in Java bytecode complicate tail call optimization on the JVM. In general, a function that calls itself with a tail call can be optimized, but mutually recursive functions cannot. Trampolines have been suggested as a workaround. Trampoline support has been provided by the Scala library with the object Scala util control. Tail calls since Scala 2.8.0. Case classes and pattern matching. Scala has built-in support for pattern matching, which can be thought of as a more sophisticated, extensible version of a switch statement, where arbitrary data types can be matched, including arbitrary nesting. A special type of class known as a case class is provided, which includes automatic support for pattern matching and can be used to model the algebraic data types used in many functional programming languages. An example of a definition of the quicksort algorithm using pattern matching is as follows. The idea here is that we partition a list into the elements less than a pivot and the elements not less, recursively sort each part, and paste the results together with the pivot in between. This uses the same divide and conquer strategy of merge sort and other fast sorting algorithms. The match operator is used to do pattern matching on the object stored in list. Each case expression is tried in turn to see if it will match, and the first match determines the result. In this case, nil only matches the literal object nil, but pivot to tail matches a non-empty list, and simultaneously destructures the list according to the pattern given. In this case, the associated code will have access to a local variable named pivot holding the head of the list, and another variable tail holding the tail of the list. Note that these variables are read-only, and are semantically very similar to variable bindings established using the let operator in Lisp and Scheme. Pattern matching also happens in local variable declarations. In this case, the return value of the call to tail partition is a tuple in this case, two lists. Pattern matching is the easiest way of fetching the two parts of the tuple. The form pivot is a declaration of an anonymous function with a placeholder variable. See the section above on anonymous functions. The list operators and both appear. Despite appearances, there is nothing built-in about either of these operators. As specified above, any string of symbols can serve as function name, and a method applied to an object can be written in fixed style without the period or parentheses. The line above is written. QSORT, smaller, a pivot to QSORT, rest. Could also be written as follows. QSORT, rest. Pivot. QSORT, smaller. In more standard method call notation. Partial functions. In the pattern matching example above, the body of the match operator is a partial function, which consists of a series of case expressions, with the first matching expression prevailing, similar to the body of a switch statement. Partial functions are also used in the exception handling portion of a try statement. Finally, a partial function can be used by itself, and the result of calling it is equivalent to doing a match over it. For example, the previous code for quicksort can be written as follows. Here a read-only variable is declared whose type is a function from lists of integers to lists of integers, and bind it to a partial function. However, we can still call this variable exactly as if it were a normal function. Scala QSORT, list, 6, 2, 5, 9, res 32, list, int equals list, 2, 5, 6, 9. Object-oriented extensions. Scala is a pure object-oriented language in the sense that every value is an object. Data types and behaviors of objects are described by classes and traits. Class abstractions are extended by subclassing and by a flexible mixin-based composition mechanism to avoid the problems of multiple inheritance. Traits are Scala's replacement for Java's interfaces. Interfaces in Java versions under 8 are highly restricted, able only to contain abstract function declarations. This has led to criticism that providing convenience methods in interfaces is awkward, and extending a published interface in a backwards compatible way is impossible. Traits are similar to mixin classes in that they have nearly all the power of a regular abstract class, lacking only class parameters, since traits are always mixed in with a class. The super operator behaves specially in traits, allowing traits to be chained using composition in addition to inheritance. The following example is a simple window system. A variable may be declared as follows. The result of calling mu in draw is in title decoration, in horizontal scrollbar decoration, in vertical scrollbar decorate ion, in simple window. In other words, the call to draw first executed the code in title decoration, then calls, threaded back through the other mixed-in traits and eventually to the code in window itself, even though none of the traits inherited from one another. This is similar to the decorator pattern, but is more concise and less error-prone, as it doesn't require explicitly encapsulating the parent window, explicitly forwarding functions whose implementation isn't changed, or relying on runtime initialization of entity relationships. In other languages, a similar effect could be achieved at compile time with a long linear chain of implementation inheritance, but with a disadvantage compared to Scala that one linear inheritance chain would have to be declared for each possible combination of the mix-ins. Expressive type system. Scala is equipped with an expressive static type system that enforces the safe and coherent use of abstractions. In particular, the type system supports classes and abstract types as object members, structural types, path-dependent types, compound types, explicitly typed self-references, generic classes, polymorphic methods, upper and lower type bounds, variants, annotation, views. Scala is able to infer types by usage. This makes most static type declarations optional. Static types need not be explicitly declared unless a compiler error indicates the need. In practice, some static type declarations are included for the sake of code clarity. Type enrichment, a common technique in Scala, known as enrich my library, allows new methods to be used as if they were added to existing types. This is similar to the C concept of extension methods but more powerful, because the technique is not limited to adding methods and can for instance also be used to implement new interfaces. In Scala, this technique involves declaring an implicit conversion from the type receiving the method to a new type that wraps the original type and provides the additional method. If a method cannot be found for a given type, the compiler automatically searches for any applicable implicit conversions to types that provide the method in question. This technique allows new methods to be added to an existing class using an add-on library such that only code that imports the add-on library gets the new functionality, and all other code is unaffected. The following example shows the enrichment of typeint with methods is even and is odd. Importing the members of my extensions brings the implicit conversion to extension class int predicates into scope. Concurrency. Scala's standard library includes support for the actor model, in addition to the standard Java concurrency APIs. TypeSafe provides a stack that includes ʻskɑː-lə, a separate open-source framework that provides actor-based concurrency. ʻskɑː-lə actors may be distributed or combined with software transactional memory. Alternative CSP implementations for channel-based message passing are communicating Scala objects, or simply via JCSP. An actor is like a thread instance with a mailbox. It can be created by system actor of, overriding the receive method to receive messages and using the method to send a message. The following example shows an echo server which can receive messages and then print them. Scala also comes with built-in support for data parallel programming in the form of parallel collections integrated into its standard library since version 2.9.0. The following example shows how to use parallel collections to improve performance. Cluster computing. Two significant cluster computing solutions are based on Scala, the open-source Apache Spark and the commercial Grid Gain. Additionally, Apache Kafka, the publish-subscribe message queue popular with Spark and other stream processing technologies, is written in Scala. Testing. There are several ways to test code in Scala. Scala Test supports multiple testing styles and can integrate with Java-based testing frameworks. Scala Check, a library similar to Haskell's Quick Check. Specs2, a library for writing executable software specifications. Scala Mock provides support for testing high-order and carried functions. Junit or TestNG, two popular testing frameworks written in Java. Versions. Comparison with other JVM languages. Scala is often compared with Groovy and Clojure, two other programming languages also using the JVM. Substantial differences between these languages are found in the type system, in the extent to which each language supports object-oriented and functional programming, and in the similarity of their syntax to the syntax of Java. Scala is statically typed, while both Groovy and Clojure are dynamically typed. This makes the type system more complex and difficult to understand but allows almost all type errors to be caught at compile time and can result in significantly faster execution. By contrast, dynamic typing requires more testing to ensure program correctness and is generally slower in order to allow greater programming flexibility and simplicity. In regard to speed differences, current versions of Groovy and Clojure allow for optional type annotations to help programs avoid the overhead of dynamic typing in cases where types are practically static. This overhead is further reduced when using recent versions of the JVM, which has been enhanced with an invoked dynamic construction for methods that are defined with dynamically typed arguments. These advances reduce the speed gap between static and dynamic typing, although a statically typed language, like Scala, is still the preferred choice when execution efficiency is very important. In regard to programming paradigms, Scala inherits the object-oriented model of Java and extends it in various ways. Groovy, while also strongly object-oriented, is more focused in reducing verbosity. In Clojure, object-oriented programming is de-emphasized with functional programming being the primary strength of the language. Scala also has many functional programming facilities, including features found in advanced functional languages like Haskell, and tries to be agnostic between the two paradigms, letting the developer choose between the two paradigms or, more frequently, some combination thereof. In regard to syntax similarity with Java, Scala inherits a lot of Java's syntax, as is the case with Groovy. Clojure on the other hand follows the Lisp syntax, which is very different in both appearance and philosophy, making the transition from Java very difficult. However, learning Scala is also considered difficult because of its many advanced features. This is not the case with Groovy, despite the fact that it is also a feature-rich language, mainly because it was designed to be primarily a scripting language. Adoption, language rankings. Scala was voted the most popular JVM scripting language at the 2012 Java 1 conference. As of 2013, all JVM-based derivatives are significantly less popular than the original Java language itself, which is usually ranked first or second, and which is also simultaneously evolving over time. As of December 2013, the TIOBE Index of Programming Language Popularity shows Scala in 31st place with 0.342% of programmer mind share, while it was below the top 50 threshold the year before. Scala is now ahead of functional languages Haskell and Erlang, as well as JVM competitors Groovy and Clojure. Another measure, the Red Monk Programming Language Rankings, as of June 2013 placed Scala 12th. Based on 15th position in terms of number of GitHub projects and 16th in terms of number of questions tagged on Stack Overflow. Here, Scala is shown clearly behind a first-tier group of 11 languages, but leading a second-tier group. The ThoughtWorks Technology Radar, which is an opinion-based half-yearly report of a group of senior technologists, recommends Scala adoption in its languages and frameworks category. According to Indeed.com Job Trends, Scala demand has been rapidly increasing since 2010, trending ahead of Clojure but behind Groovy. Companies. In April 2009, Twitter announced that it had switched large portions of its backend from Ruby to Scala and intended to convert the rest. Guild uses Scala and Play framework. Foursquare uses Scala and Lift. In April 2011, The Guardian newspaper's website guardian.co.uk announced that it was switching from Java to Scala, starting with the Content API for selecting and collecting news content. The website is one of the highest traffic English language news websites and, according to its editor, has the second largest online readership of any English language newspaper in the world, after the New York Times. The New York Times itself revealed in 2014 that its internal content management system Blackbeard is built using Scala, క్కः and Play. The Huffington Post newspaper has started to employ Scala as part of its contents delivery system Athena in 2013. Swiss bank UBS approved Scala for general production usage. LinkedIn uses the skala micro-framework to power its Signal API. Meetup uses Unfiltered Toolkit for real-time APIs. Remember the Milk uses Unfiltered Toolkit, Scala and క్కः for public API and real-time updates. Criticism: in November 2011, Yammer moved away from Scala for reasons that included the learning curve for new team members and incompatibility from one version of the Scala compiler to the next. Others criticize Scala for lack of readability regarding implicit parameters, that it is not possible to avoid Scala's more arcane features once one needs to pull in a library that uses them, and that overall, Scala's difficulty outweighs its value. See also: SBT, a widely used build tool for Scala projects. క్కः, a concurrency framework written in Scala. Play, an open-source web application framework that supports Scala, Circumflex, web application and other frameworks for Scala. Lift, an open-source web application framework that aims to deliver benefits similar to Ruby on Rails. The use of Scala means that any existing Java library and web container can be used in running Lift applications. skA:lə, a very minimal web application framework built using Scala. References. Further reading. External links: official website, TypeSafe company website, Scala forum, Scala communities around the globe, Scala IDE, open source Scala IDE for Eclipse, Scala Tour, open source Scala Tour, interactive tour, a tour of Scala.